what if we could harness the mechanical vibrations or the movements of everyday objects we interact with, including our own body, and convert that into electrical energy?
So this opens the doors for some really neat applications. One thing we're looking at are traditional transmission or engine mounts used in vehicles that are just normally passive. But if you could potentially make these materials piezoelectric, then you could simultaneously damp out vibrations and harvest energy.
So anywhere where we can scavenge normal everyday mechanical motions and turn it into electricity, that saves energy, that eliminates batteries, that eliminates so much use of fuel. We're starting with an idea that's been around for a long time: piezoelectric materials.
The standard paradigm in piezoelectric materials really is brittle ceramics, polymers that have rather limited compliance and limited stretchability.
We want to harness the mechanical motions from places that really move and flex. So we need something flexible like rubber. And so here's the scientific problem. So what we're doing is, and scientists have already known, that you could grind that ceramic material up into little chunks of powder about the size of our red blood cells, mix that in an elastic material like rubber. If you think of a normal piezoelectric material, it's a brittle ceramic, and think of it as a battery that only makes electricity when you squeeze it or when you try to bend it. So now you're breaking the piezoelectric materials up into little mini batteries, but the problem is they're not connected to each other. And so one of the things we're doing is we have to embed special nanomaterials called carbon nanotubes to act as little wire connectors between the chunks. And the beauty of the carbon nanotube is very strong and flexible, so as the rubber stretches, those connections can stretch with the material. Our next steps would be optimize the material, make it better, and figure out how it works so we can make predictive modeling for it.
We want to develop models that allow us to optimize devices. Those models will then predict how an actual device will perform.
That's what this model is going to allow us to do: predict what are the best shapes and the best motions to get the most electricity.
We hope through fundamental materials research that we can change the landscape of energy harvesting.